Hello my dear students, today I am going to solve some questions from SN1 and SN2. Actually, I have made two videos on SN1 and SN2, the differences between SN1 and SN2 in one video, stereochemistry in SN1 and SN2 in another video. Now today, we will solve some questions based on SN1 and SN2 from previous year JEE mains and advanced examinations. So let's see which type of model comes in competitive examinations. So let me solve these questions. First, you see this question. So this question came in advanced examination. A solution of plus 2-chloro-2-phenyl ethane. So it is clear plus 2-chloro-2-phenyl means that is optically active. One of the enantiomers of 2-chloro-2-phenyl ethane in toluene racemizes slowly in the presence of small amount of SbCl5. Some reagent we are given due to the formation of what? You see, this is in fact the simplest question, because we know from stereochemistry, without stereochemistry even we know that in SN1 carbocation formation takes place. Then SN1 carbocation formation takes place. Now you go to stereochemistry. In carbocation, attack of nucleophile takes place from both front side as well as back side. So racemic mixture formation, racemization takes place in SN1 mechanism, not in SN2. In SN2 strictly inversion takes place. So as per the given information, it is clear that the racemization, racemizes, it means the mechanism should be SN1 mechanism. It is a secondary haloalkane. So secondary haloalkanes undergo both SN1 and SN2. So as for the given information, the racemization means it should be SN1, and in SN1 no carbon free radical. Carbocation is the intermediate, and these are incorrect options. And there is no doubt, because from the given options you can easily understand that in SN2 neither of these intermediates is formed. We know in SN2 there is no intermediate, in fact only transition state is formed. So intermediate is formed only in SN1 reaction, and that too haloalkane we are mentioned, racemization SN1 carbocation. Straight away question. And well, another JEE advanced examination question from SN1 and SN2. Let's see this particular question. So when we are given this question, it is clear that phenyl S minus, phenyl group is given. So this is a nucleophile. Sulfur donors are strong nucleophiles, no doubt. Okay, but still, you see, without any confusion, lot of information has been given in this question. DMF, you know, dimethyl formamide, that is purely polar aprotic solvent. So polar aprotic solvents always favor SN2 mechanism. So there is no doubt. And here fluorine, bromine, two leaving groups are there, but fluorine is haloarene, this is haloalkane. You already know that haloarenes are very much less reactive than haloalkanes. So that's why substitution is not possible here. If you think substitution is possible in benzene ring, then again bromine is a good leaving group than fluorine. So no doubt substitution takes place at this position. And we know in SN2 inversion takes place. Now nucleophile comes like this, because hydrogen is present like this. Now we can imagine hydrogen in broken line. Leaving group is given in solid line. So in inversion, nucleophile comes in broken line, and as usual in this hydrogen is present. So inversion, typical inversion takes place in SN2. So this is an example of SN2, and at fluorine being a haloarene, it cannot undergo nucleophilic substitution easily. We know this is directly NCERT concept. Well, let's talk about next question. We are given haloalkane neopentyl bromide, it is okay, and ethyl alcohol, ET stands for ethyl group, and heating directly given. But you see, ethyl alcohol, and there is no other reagent, directly haloalkane is taken and that is dissolved in ethyl alcohol. Ethyl alcohol is a polar protic solvent, and its solvent itself acts as a nucleophile, and this type of reaction is, we know, solvolysis reaction. Solvolysis in generally follows SN1 mechanism. Okay, so in SN1 we know intermediate carbocation is formed. Intermediate carbocation, this bond breakage takes place, carbocation intermediate. Now you check 1,3 methyl shift is possible or not. Let's check. Initially it was primary carbocation, now it is tertiary carbocation. Yes, this rearrangement is quite possible. After this rearrangement, you do one thing: ethyl alcohol being nucleophile attacks this carbon, OET. ET stands for ethyl group. Okay, no confusion. So this is our final product, unexpected product. Okay, because you know, once carbocation is formed, there is a chance of rearrangement in carbocation. So after rearrangement, this stable tertiary carbocation is formed, and now ethyl alcohol being a nucleophile attacks that, and that gives final product, this one. And now let's talk about question number 4. This is also SN1 and SN2 based question. I mean nucleophilic substitution based question. Actually, nucleophilic substitution is a very vast topic. Nucleophilic substitution takes place in haloalkanes. Okay, in haloalkanes only we talk SN1, SN2. Haloarenes it takes place, that is ARSN. Alcohols it takes place SNI, SN2. Ethers it takes place, acid derivatives, but our class is totally relevant to SN1 and SN2. And this was the given information in the question. SN2 was mentioned in the question, no confusion, directly inversion takes place. Ethyl group, methyl group, carbon, this is chiral carbon. Inversion means backside attack. Okay, reverse this one. Hydrogen comes here after going off leaving group. This particular nucleophile is present opposite to the configuration of this bromine. Now let's see next question. We are given these 3 compounds and we have to identify correct order of reactivity towards SN2. Options were given, but still we can solve this question. There is no problem. So we know that methyl halides are most reactive towards SN2 and tertiary haloalkanes are least reactive. So is there any methyl here? No, methyl is not there, but primary is there. When primary is there, means primary haloalkane is no doubt most reactive than secondary haloalkane, because in secondary also SN2 takes place. Tertiary there is no chance for SN2, that should be the least reactive always. Okay, let me solve this question. Also we have some other questions, I will explain. So in this question we are given total 4 compounds, but the question was most reactive towards SN2. I mean in which compound inversion, stereochemical inversion takes place at highest rate. This was the question. Means inversion in SN2. SN2 was also mentioned in the examination. So we have to find the species which is the topmost reactive towards SN2. That should be methyl. We know very well. Let's check, is there any methyl? Yes, methyl is there. Okay, methyl halide is most reactive and least reactive is this one. But the question is simply the most reactive towards SN2 mechanism, that is directly methyl halide. Okay, because we have to discuss point to point what has been asked in the examination and what to answer point to point in a concise manner. Let's solve 2 to 3 more questions which have been asked in previous JEE mains and advanced examinations. Okay, these are also actually brain exercise based questions. I think total 6 questions are over. 7th one is this one. This was the given information in the examination. As per the question given in the examination, I am directly writing like this. Next you see, this was the question from SN1 reactivity order. SN1 reactivity order. Out of these 3, you have to find correct order of reactivity towards SN1. And one more question based on SN1 and SN2. SN2 reactivity order. Okay, These are all questions from previous JEE Mains and Advanced, 9 model questions. So very nice question it is, because we are given a reagent in which we know Cn minus is an ambidentate nucleophile. Okay, Cn minus no doubt is a strong nucleophile, negatively charged nucleophiles or strong nucleophiles, but on the basis of nucleophile we cannot decide SN1 or SN2 mechanism. Okay, already I taught. So you see the substrate, this is haloarene, this is chloroalkane, means this haloalkane portion, haloarene portion. Haloalkanes are more reactive than haloarenes. So here reaction does not take place. Iodine is retained as usual. Now this is a primary haloalkane, no doubt methyl and primary undergo SN2 mechanism. Okay, strong nucleophile that favors DMF, dimethyl formamide, polar epirotic solvent, all factors favor SN2 mechanism. Okay, no doubt, but there is no stereochemistry here because this is not chiral carbon atom and directly SN2 is SN2. Okay, if you are asked about mechanism of this reaction, then also you can easily find straight away SN2 mechanism. And we are given 3 compounds in next question, and we have to find the correct reactivity order towards SN1. We know very well for SN1 reaction you have to compare the stability of intermediates, because SN1 goes through carbocation intermediate. So this particular reactant gives this carbocation after breakage of this. After breakage of this particular one gives this carbocation. This one gives this carbocation. And what about this? After breakage of this, it will give this carbocation. So now which is most stable? This is most stable because the resonance is there. This is allyl carbocation. So allyl carbocation is no doubt resonance stabilized. So it should be the most stable. So most reactive one is this one. This is the most reactive one. After that you compare these two. So this one has only 2 alpha hydrogens and this one has 3 plus 2 alpha hydrogens, 5 alpha hydrogens. So primary is always less stable than secondary carbocation. So it should be second most reactive and it should be least reactive. Okay. So allyl one is always most reactive. Allyl moreover it is secondary. Okay, secondary. From this side it is also stabilized by hyperconjugation, but moreover anyway when we talk about all together it is resonance stabilized, and in any other structure resonance stabilization is not there, so it should be the most stable carbocation. So this is the correct reactivity order. Not only SN1, in any reaction you see if intermediate is more stable, then rate of reaction is more, that reaction is faster than other reactions. Let's solve final question on today's session. That is this: we are given 4 compounds. We are asked to write the correct order towards SN2, not reactive, most reactive or least reactive. So order, order of reactivity towards SN2. So how to write? We know towards SN2 methyl halide is always most reactive. After that primary comes. This is the primary one. After that secondary comes. Tertiary is always least reactive. That question, in the question the given order is already the decreasing order towards SN2 mechanism. Okay, so these are very important questions. For further examples you can go through DPP or assignment both. Okay, for board level questions you see this model are board level questions. For other practice for board examination you can go through NCERT in text and exercise questions. Okay, thank you.